Hey guys, welcome back to another video. So I've been getting quite a few odd requests lately. One of them is actually from quite a few people, which is, why don't you put your face out there? You know, all the other teachers are doing it. I thought, you know what, guys? How about it? So as we get started, I'm just gonna ask you guys to let me know your feedback after this on whether I should keep my video on, or is it a bit distracting? Is it pointless? Does it add anything? Does it add absolutely nothing? But yeah, either way, how about we go straight in and see how this paper goes? And yep, I did not shave, so wow, damn. All right, let's do this complete walkthrough right now. Okay, so number one, the table below shows corresponding values of x and y for this given function here, with the values for y rounded to 3 decimal places where necessary. Okay, so we got x values here, and we got a table which also consists of y values. Now they've done everything but x equals 15. So let's read part A. A. Complete the table by giving the value of y corresponding to x equals 15. Now, this is straightforward. You literally just have to replace this x value here with 15. So you, in your calculator, you can use a fraction button or any scientific calculator and write 1 over the square root of bracket 15 plus 1 and get your answer. You can actually do it mentally, and if you do, you should get 0.25. Okay, not bad. B. Use the trapezium rule with all the values of y from the complete table to find an approximate value of this integral. Now note guys, yeah, we never evaluate integral because this is something you do at the C3-4 level. You're not taught how to integrate this. You could actually integrate this, but you'll get no marks because they specifically tell us to use the trapezium rule. So what is the trapezium rule, yeah? Well, the trapezium rule tells us that this solution here will be equal to some change over x, so let's call this delta x, change over x, divided by 2, times the first and last y position, so let's call it y0 plus the last one, yl, plus 2 times everything in between, so all these values in between, so the rest of the y values between. And yeah, so now we just evaluate this. The actual formula looks a bit different. Instead of changing x, they use a h, which just means the difference in the x values. So what do we have? We can see that the change in x between each one is going up in threes. So that's going to be our delta x, so it'll be 3 over 2. Our first y value and our last y value, so the 0th and the last, is 1 and 0.25. So just put that in. And guys, you can just put this all in your calculator. Maybe just show the working out, but full answer in the calculator. Now for the rest of the y values in between, we're talking about these lot, yeah? So literally put all of these lot in the calculator. So you can just sum them up right now. So it's going to be 0.5 plus dot 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 plus all the way up to 0.277. Close the bracket and then close the other bracket. And then simply just run it through your calculator. And when you do so, and I've done it before, you should get an answer which says exactly 6.288. Now we're gonna be careful here. It says give your answer to 2 decimal places. So 2, yeah. Here we got 3. So therefore we're gonna round this up to 6.29. Yeah, and that's one done. Okay guys, number 2. So we're given a function which is a cubic and it has a and b in it, which is unknown. Now it tells us when this function is divided by 2x minus 1, the remainder is 1. Now what this tells us exactly is that when you divide it by a linear term, it's trying to say that when you set this to 0 and you solve to find the value x, which comes out to be a half, you would plug this half into this function and it should equal to 1 because that's what the remainder would be. So let's do that right now for a second, yeah? So let's go ahead and replace all these x terms with a half. So we can say that the function at the point half is going to be a times half to the power 3, and in your calculator that's 1/8. That's so a times 1/8 is a over 8 plus, and now in your calculator just put all at once, 2 times half to the power of 2, and that's going to give us 2 times a quarter, which is a half, plus bx, so b times a half is b over 2, minus 3. And all of this, as we know, should give us a remainder of 1, so equal to 1. Now, the objective is to make this equation here look like this one here, a plus 4b equals 28. Now we're almost there. We got an a, we got a b, we got a bunch of numbers. It looks to me you're going to get 28. But to make it nice and easy, let's go ahead and clear the fraction, because there's no fraction involved. So times all of this by 8. Okay, let's do that now. So times in all of this equation by 8. I'll change my pen. So a over 8 times 8 becomes just a plus times the half by an 8, you get 4 times b over 2 by 8, you get 4b, and then times, and you know what we could do, just let's add 3 across. So 1 plus 3 is 4, and then multiplying 4 by 8, you should get 32. And now it's straightforward. Now we go ahead and just subtract 4 across, and therefore we got a plus 4b equals 28. Alright, so that's the first part done, and that was 2 marks. Yep, sounds right. Now next one, when the function is divided by x plus 1, the remainder is minus 17. So same thing applies. When you set x plus 1 to 0, you're going to plug in the value of x equals minus 1 into the original function, and the remainder, and it should equal minus 17. Find the value of a and b. Okay, so we're going to do the same thing to obtain another equation. Let's do it right now. So replacing x with x cubed minus 1, so it's going to be, so I'm going to go down a bit. Yep, that should be okay. Okay, so part B. We're going to have minus a. Now replace minus 1 in the x squared, it becomes positive 1, so 2 times 1 is plus 2. You can put this on your calculator, just the normal numbers. Bx becomes minus b. And then minus 3, and it must equal a remainder of minus 17. So we just go ahead and tidy this up a bit. So what we could do is 2 take away 3 is minus 1. Add it across, you get minus 16. And on the left side, you got minus a and minus b. Now just to make it look nicer, I'm going to go ahead and move minus a minus b across to the other side and minus 16 to the left. So then everything goes positive. Okay, so therefore a plus b equals 16. Now looking at both these equations, you can see we've got pair simultaneous equations. So what we have to do here is use your new equation here and your original equation here and just subtract them. So let's go ahead and line them up first. So the first equation was a plus 4b, and that equaled 28. Second equation, a plus b equals 16. So what I would do, I noticed that the a's are the same. Let's go ahead and subtract the whole thing, yeah? If you subtract it, the a's cancel out. 4b take away b is 3b. 28 minus 16 is 12. And then, yeah, you're done. And then now just dividing 3 across, you're going to say that b is going to equal 4. And since b is 4, use the second equation here. A plus 4 is 16, so therefore, subtracting 4, a must be 12. And yeah, guys, that's number 2 wrapped up. Okay, number 3, guys. So, the line L1 passes through the points A and B at certain x and y values, alright? Find the gradient of this line, L1. Okay, so this is straightforward, standard formula. So to find the gradient, it's just simply the change in the y coordinates over the change in x. So right here, change in y over change in x. We have 2 coordinates, we just find the difference of the y's and x. So what I'll do, I'll just say, find the difference between B and A. So you can say difference in the y would be minus 8 take away 4 over the change in x, 5 take away minus 1. So 5 minus 1. Now I wouldn't bother working in our heads. You might as well just put this in your calculator, and when you do, you get a perfect result of minus 2. And that's it, that's our gradient, minus 2. Now, part B. The line L2 is perpendicular to the line L1. So perpendicular means that the line is moving in this direction at 90 degrees. If this was L1, then this must be L2. If this was a gradient of minus 2, then the gradient here would be the negative reciprocal. So if it was minus 2, it will become a positive, and reciprocal 2 is half. So that's our new gradient, positive half. Okay, and it also passes through a point, B, 5 minus 8, which is the same point. Find an equation for L2 in that given form. Okay, so this isn't too bad. We just use the standard y equals mx plus c. So using y equals mx plus c, we just need to find m and c and then make it look like that form. So m, we know the gradient is half, so therefore y equals half x plus c. We also know it passes through a point B, so it passes at b, which is 5n minus 8. Now the beautiful things about these y equals mx plus c equations is that all you got to do is find the value c if you know what x and y are. We know what x and y are. It's 5 minus 8. So we can say, therefore, replacing the coordinates of y is minus 8 and x is 5, we're going to have an equation that looks like minus 8 equals half times 5, which is 5 over 2 plus c. And then go ahead and making c the subject. I'm going to go ahead and subtract 5 over 2 across. So therefore, c is going to equal minus 8 minus 5 over 2. Put that in your calculator and you should get something like c equals, what I get? Minus 21. Nice. Now, since we got our equation, just replace that c with what you got. So therefore, our equation of line 2 equals half x minus 21 over 2. And voila, we're done. Now, just being careful, they told us to make it look like this form, where a, b, and c are integers. Right now, they're fractions. So let's go ahead and clear the fraction. And the best way to clear it, the all over 2 times the whole lot by 2. So times this equation by 2, we're going to have 2y equals half x becomes just 1x, so x, 2 cancels out, minus 21. Now we're going to make it all equal to 0. And it's going to be x first, then y, then a constant. So x is here. I'm going to move 2y to the right. So it could be 0 equal x minus 2y minus 21. And just to be safe, equal 0 is on the right. So therefore, we're going to have x minus 2y minus 21 equals 0. And that's it, guys. This is it for my video for the first fifth of this paper. So what I usually do from now on, at least from this recording, is that if the paper is 2.5 hours long, I'll do, and if there's 15 questions, I'll do 3 per video. If it gets, if I do it too quickly, then I might do 4 or 5 questions. Or if it's too long, I'll do 2 questions. But either way, guys, I would like your feedback. Let me know what you guys think. If you enjoyed my video, give me a like, and I hope to see you guys soon. But other than that, have a nice day, and I'll see you soon, inshallah.